Hey guys, welcome back to another live stream. This time we're continuing where we left off in the last one. So in the last video, we're building this humanoid robot. I've attached a picture over here. And in the last video, we worked a bit on these encoders. We did some soldering. The camera is in a different location this time. But yeah, today we're gonna be working in parallel. So today we're gonna be working on the assembly of the robot, putting together all the 3D printed parts, and we're gonna be working on wiring as well. So that's why we have sort of two setups going on over here. On this side, I'm gonna be working here with the wiring. I'm gonna be joining wires with these encoders over here. These are all the encoders we showed in the last live stream, and I have a lot of 14 gauge wires over here that we're going to be attaching to these. I have prepared these wires in advance. They are about the correct length, and in parallel over here we're going to be on this side, we're going to be working on the 3D printed parts, and we're going to be assembling
the actuators. So over here we're gonna be assembling the actuators. First of all, I need to insert brass inserts in all of these actuator parts from here, and once we have done that, we also have the bearings, which we will add right about here, the bearings, and then we're gonna try to assemble the actuators. We'll see how many we can do tonight.
Yeah, so regarding the parts, we have basically all the parts ready. We have a lot of brass nuts over here. These are the ones we need. These are M3 and M2 brass nuts, and we also have all the controllers for the robot. So these also arrived yesterday. We're gonna be soldering the wires to this. So from these encoders, the wires are gonna be going to signal wires are gonna go to these controllers, and they're gonna control the motors. We have all the motors as well. So yeah, let's start working on it. So once again, we're gonna be working in parallel. So here I'm gonna start assembling the wires. I'm gonna solder them onto the encoders.
Alright, let's get started. It's gonna be a long night ahead of us. So this is actually just a sprint. We do not know because this is our first time assembling these actuators. We genuinely do not know how much time this is going to take, but we're going to move as fast as we possibly can, in parallel working on the electronics as well as the mechanical part, and we'll see how many actuators we are able to assemble in the next few hours while we are live. So yeah, let's get started with it. By the way, these parts which were really necessary for the actuators, they just arrived a few hours ago. Like literally the delivery happened just a few hours ago, and we just picked up the parts from our friend and got right to the assembly.
For some reason, the official documentation for this humanoid robot, it is recommending the 14 gauge wire to be used over here, but the wire is like it is too thick for the solder pins on the encoder, as you can see over here. Like it's literally impossible for it to pass through here. So I'm gonna try to cut these wires from the tips, and I'm gonna try to insert them and solder them that way. So it's gonna take much longer than I initially thought.
Yeah, this genuinely needs a sprint for a few hours, and even then we'll see how much progress we're able to do. There's a lot of work to do. First of all, we have to assemble all of the individual actuators along with its wiring and BLDC motors, And after that we have the aluminum profiles, if you can bring from there. So like we have the aluminum profiles for the base structure. We have to connect all of the parts with this, and even then it's just the aluminum profiles and the actuators. The arms of the robot, the legs of the robot, they are still separate parts, and we still have to attach them with the actuators afterwards. It's a maybe it will take us 2 days, 3 days, we literally do not know. So for now we're just gonna be sprinting as fast as we can, and yeah, let's see how much progress we're able to do in this live stream.
Yeah, I would recommend you to take your sweet time when building this robot. You should have a flexible timeline, because initially if you have not started working on this, the 3D printing itself, it takes a whole lot of time, and during 3D printing you need to make sure you have ordered all the required components, and there are a lot of components for this. Sometimes I mean, certain manufacturer won't have those parts available in bulk. A really good example of that is bearings. Like, there are lots and lots of bearings. I would say probably hundreds of bearings in this robot.
Yeah, in total there's hundreds of bearings.
Yeah, and it's difficult to find it. In our case, at least, it was difficult to find it at a single location on Amazon. So we had to go through different manufacturers to get all the bearings. This wire is still not going through, and I'm gonna have to double check the gauge on this wire, because this wire is really thick. It's not passing through the holes in these encoders. Let me check again.
To remain in this one.
Yeah, so since those wires are big, we're gonna be going forward with 24 gauge wires we have over here.
I don't think these are 24, these are 30
These are 30 gauge wires.
Yeah, I don't think the BOM, the bill of material, mentions 24 gauge wires anywhere.
Okay.
That's strange.
Yeah, so these wires, I don't think they're gonna cut it. It's gonna be really difficult to make these wires work on these encoders. We might have some other wires available in our lab that we can make use of.
Are the 14 gauge ones, they're not fitting at all?
Yeah, they're not going through. Like, by the way, if you ever need to do this to a wire, it is not recommended to like ever cut a wire, because these pieces, if they're like spread around in your lab, they can be really harmful. So if you ever need to cut down a wire to size, you probably need a smaller size wire or a bigger gauge wire on that module or encoder.
Alright, there we go.
Yeah, so
this part is done. Now I am going to attach these on the other parts of the actuator. How much gauge is this one? I hope 24.
this is 20 gauge.
20. I think we can make use of it.
Yeah, for now at least, I think we can make use of it.
For the prototype, we do have to
Yeah, so we do have blue, we have yellow, we have red, and for ground, I think we're gonna be using the. I don't think we have the green one here at our lab, so we're gonna be moving away from the standard wiring Yeah.
Yeah, it's okay. We can identify. Color coding would have helped a lot, but I guess
Yeah.
we don't have much of an option.
Can you place these modules a bit towards here to the center so
Okay.
it's in the camera? Yeah.
This one's done, and now we'll move on to the next one. Alright, next up we have this part, and this one is gonna take in M3 as well as M2 hex inserts. So these are M2 and these will be M3. Alright, let's start adding these one by one.
Can you double check what gauge these wires are? It's
These ones?
always like a good idea to have a lot of components in your lab, or at least do this in a facility where you have access to a lot of components. For example, in this case, in the bill of materials, we ordered all the required items. We had the 14 gauge wire, the 13 gauge wire, but now we've discovered for the encoder, neither of those wires are how do I put it? Neither of those wires are efficient to be used on those encoders. So we have the wire they are using on the encoders. They recommend it's 24 gauge. So we had 20 gauge lying around in our lab, and 20 gauge is slightly thicker than 24 gauge. So it's a safe option. Otherwise, it was gonna add like 8 to 9 hours delay when the markets were gonna open in Akihabara. So it's a good idea to do it somewhere where you have access to a lot of materials that you so you have the wiggle room with your deadlines.
Does Conan Pro have wires?
I don't
Most
know.
likely. Did you?
I don't know if they specifically deal with gauges. They probably
Yeah.
should, in my opinion, but we don't know for certain. Let's check it the next time we're in Conan.
Yeah. Bill of
A little bit
material
here.
is like a huge deal. So supply chain logistics or bill of material, basically procurement of materials in hardware projects is just like a huge department of its own. And oftentimes in a complex project, there's a lot of materials that you really want to make sure they're delivered on time, so that way the project does not suffer any delays.
Yeah, and a lot of times it's difficult to find a specific product in your country. For example, in our case, we're building this in Japan, and we looked everywhere for these motor controllers, and in our case, these arrived from DigiKey, which is in USA. So the shipping takes a while, and no market in Japan had these motor controllers. So we had to make sure to order these in advance. A lot of hardware components can be ordered from China, or in China is also cheaper when it comes to ordering stuff in bulk quantities. If you want to buy it from your local market, it might be a bit expensive. So it's a good idea to order a lot of these screws, T-nuts, slots, general hardware equipment in advance. So even if you miss something or you're running on a tight deadline, you have access to all the materials. Temu is a really good option for that. Alibaba, generally the products they have listed there, they require you to buy in bulk, or you have to negotiate with the store owner or the product supplier. But Temu has a lot of good options when it comes to hardware stuff I've seen. In fact, you can fill up your lab for very cheap if you go that route.
Yeah, and it's always a good idea to have most of the commonly used parts in hardware and robotics, like maybe wires and all of the tools, in your lab all the time, because you never know when you're gonna need to sprint on a project. So especially the tools, once again, which are very common, you need to have a stock of them at the lab. It's around 2:30 in the morning. Night. Night time. So very early before the morning.
Yeah, generally the same thing. So while building our project this time around, I have to now move away from the convention because we don't have the wires. It was they were not listed in the bill of materials. So if you're watching this and if you want to build the humanoid robot, the open source one from Berkeley UC, you need to also order and have in stock the 24 gauge wires.
Yeah.
They are used on the encoders and they are not mentioned in the bill of materials. So I would recommend ordering those if you're planning on building this robot. Otherwise, if you have around 20 gauge or something like that lying around in the lab, you can move away from the conventional coloring scheme. I don't understand why they have used a blue wire for ground anyways. Generally black is the best color for ground.
Oh, they're using blue for the ground?
Yeah. So, but if you build the robot, it's not gonna be difficult to like recognize the colors or troubleshoot if any linkage is not working or something like that.
Yeah. And we can always make edits later on, but I think just for initial working, just for initial prototype, I don't think this much difference of a gauge is gonna matter much. It's this 20 gauge wire is gonna work just fine.
Yep, absolutely. We're running a bit low on the ground wire, but I think I don't think we're gonna run out of it. Doing 22 encoders they were. How many were?
Yeah, there's 22 in total.
Yep. There is one part for this robot that still hasn't arrived yet, and that would be the USB to CAN adapter. And we really need that thing to move the robot by using microcontroller or code. This is the last one. But other than that, today we should have assembled by the end of this live stream. We should have a lot of actuators that we can move around with hand, and
Hopefully, yeah, we're all good for this live stream. There's a lot of work to do, a lot of work, and even then we're not sure if we're gonna be able to assemble all of the actuators, let alone the hands and the legs during this live stream. there's a lot of work to be done yet.
After this, once this project is done or we're done for the day, I would really like watching some anime episode. These days I am watching Kaiju number 8, the second season. It's still airing, I think. I'm not sure if all the episodes are out yet or not, but so far it's going good. It's not like it's the typical shonen anime with a lot of fight scenes.
Yeah, it doesn't really have a lot of depth, but it does have those really good action fight scenes.
Yeah, the story is not, of course, not the best. It's not even average, to be honest. But if you're like bored from work, or if you just want to consume something, I think it's really good.
Not even average. It is, the story is basically nothing. He just wants to fight alongside the person, and that's just the whole plot.
And it's a very typical, very cliche story, just like Naruto sort of cliche. Naruto World had a lot of depth to it though, but a lot of anime recently they've just been like cutting bits from these the top 3 shonen animes, like especially like Black Clover. It had bits from like all the animes out there. There are very few like original good paced anime out there. I don't think we have seen any this season, but Frieden last season was so good. It was I'm really looking forward to the second season, but it was a really good change of pace from the typical shonen animes we were having.
And by the way, us discussing anime while building this humanoid robot is so much like tech Twitter. Like people who have anime profiles and turn out to be the most genius and best coders of all time, or building humanoids or robots.
Yeah.
So
we are
so
we're that tech Twitter except the genius part. We're just trying our best, guys. Yeah. So, but I haven't watched a lot of slice of life animes like that, or school life sort of animes. I've mostly watched the typical shonen or the like top anime seasons from the year. But if you guys have some decent recommendations, story wise especially, yeah, drop them in the chat. I would love to watch them.
These M2 brass inserts are so small. Like you can see this one insert. It's so tiny. They also need to go inside of this actuator part. Let's try inserting it over here.
We're gonna be now. I'm gonna try and use these wires and solder them onto these encoders. They seem a bit more reasonable compared to the last 14 gauge wire I was trying. So yeah, it was a real clutch having this lying around in the lab.
Yeah, really saved the day.
Yeah, first off I'm gonna make all the VCC connections, I guess. Either way, whatever order we're doing this in, we're gonna have to solder all of these. They have a nice ring to them. Huh? If you guys are listening to this point and you guys watch anime, I would love to hear some anime suggestions down in the comment section below. I would like to learn what's your favorite anime. That's a controversial topic, but everyone has like their really strong opinions on that, but my favorite is One Piece. I really love that show. Yeah, it's gonna be a bit difficult to fit this wire as well, but I'm gonna twist it and try to fit it somehow.
I don't think there's gonna be a lot of controversy regarding this. I think people who have watched One Piece would sort of
No,
not.
but a lot of people are not like shonen fight scene adventure sort of minded. A lot of people like slice of life or romance animes or school life
Yeah.
animes, things like that. And also, One Piece is such a long
It's really
show.
long.
People that complain about the length of the show, they really hate it with a passion. They really make sure to tell you that.
Yeah, it is quite long. It does take a lot of time to go through all of the episodes and catch up. It's been going on for what, like 20 years now, or 20
Mm.
plus.
Yeah, I think that's the power of that anime though. Like, you grow up with it, and yeah, it's just flowing with you with all the rest of your life. Whatever's happening in your life, it's just one thing that continues along with it.
Alright, this part is also finished. By the way, we have to do this for 22 actuators in total, and only this one actuator is taking so much time. So like today's work is not very technical. You don't have to apply a lot of your mind or solve problems. It's not like technically deep. It's just manual labor, repetitive sort of work, but it is time taking. So we have to do this for 22 actuators. This hardware mechanical part, as well as the soldering and electronics work that is going on over here. Alright, moving on to the next part. Okay.
We have our first solder of the day, guys. Cheers.
Let's go. One
Cheers,
step at a
guys.
time.
We have the first solder of the day. Let's go. Yeah, so this wire, as expected, it's slightly thick, so I had to cut the part of this wire to make it fit in the hole over here. So yeah, you would need that 24 gauge wire for this encoder. Otherwise, it's gonna waste a lot of your time trying to cut that wire and trying to sneak it in that hole over there.
Okay. First one done on this part. Moving on to the next one.
VCC, and I'm gonna be using black for ground. Because of the slight mishap in the components, because we were not able to order everything because they were not mentioned in the bill of materials, this soldering is not turning out to be the most pretty, but I'm trying to cut this a part of these wires, and as you can see over here, and then we can twist it and we can try to wiggle it in the encoder hole over here.
Alright, great. moving on to the next part.
When is the next season of Rerun coming up? I think it should be this year, right?
Not sure.
Yeah, I will have to double check that, but I'm so excited for that season. It's such a breath of fresh air
Yeah.
compared to the rest of the. Yeah, it's really slow. It's really slow.
It's like-
I wonder if today's kids can handle it.
It's a really slow touch grass nature sort of like
Yeah.
it's really slow and
Yeah, I wonder, Gen Alpha, because their brains have been, especially because of that Italian brain rot that's going around lately. If you guys don't know about the Italian brain rot, I don't recommend you ever check that out. It's like so messed up. It's so Gen Alpha, but especially also because of the TikTok and the way that algorithm messes up with your brain. I wonder if they are able to enjoy a slow show like Free Reign. Shout out to all the Gen Alpha viewers in the chat if there are any. If you are a Gen Alpha and you enjoy Free Reign, definitely let us know.
coming out pretty neat. After these brass inserts, we have to insert bearings on this.
Yeah.
2 more to go. Let's continue.
Yeah, on my end, the soldering is not the most efficient because of the difference in the gauge. Yeah, but like we were discussing earlier, this is the biggest problem in terms of building something like that, the material procurement and material gathering, because if you mess up even a single wire, it wastes so much of your time, and you have to go through you have to jump through hoops. It takes a lot more time.
Alright, last one for this part.
Yeah, I hope it stays in place now, because yeah, these wires, we have to wiggle them in. They're not like meant to be soldered onto these pads, and it's difficult to get them to sit in place. But yeah, 2 more wires to go for this encoder. We're gonna attach an SCL wire over here and an SDA at the bottom. And once again, we're gonna move away from the convention because we could not arrange the wires on time.
Alright, this part is done. We're gonna start attaching bearings on this one now. So, the smallest bearings that we have, I think we're gonna have to. We've not even unboxed them yet, I think. We're gonna have to find.
We have a lot of bearings
Oh.
over here.
Yeah,
these bearings,
these are the
bearings. So this robot, if it's made of one thing, it's bearings. There are hundreds of bearings in this design, as you can see.
Yeah, there's 13 bearings needed in one
Yeah.
actuator. 13 bearings only a one-time type. There are more than 13 bearings needed for one actuator, and there's 22 actuators in total.
Yeah, there are like so many bearings, especially over there as well. If you can bring,
Yeah, so like
Yeah, these are all bearings as well, guys. As Mufasa would say to these, everything the light touches are bearings.
it's a 10x T3 bearings. These
Yeah,
ones.
so many bearings for this like robot.
Um, all of these bearings are they're exactly same size. They're the same bearings, but they're from different suppliers. So the color is different, but the size is the same. I'm pretty sure they're exactly same bearings. We're gonna use the black ones for this one. Blue ones I'm gonna keep for later actuators. Let me open these black ones.
So I'm gonna be using blue wire for SCL now because of the issue with material gathering.
I think for now I'm gonna turn off this soldering iron.
Actually, I need to use that. I need
This
to
one?
use
Okay.
that. Yeah.
You can
This one is much better to use compared to the one I'm using right now.
careful.
This is a 40-watt soldering iron, and I found it to be really. It's been my buddy in all of these projects. It does the job really well. Yep, it's doing the job much better. If you don't need it right now, I'm gonna turn mine off. If that's okay, or
Yeah,
we
you
can
can-
just switch the places of these. I think you can make use of the.
This one for
15 watt?
brass inserts.
I think so, but
Alright,
okay.
okay.
You're gonna use this again whenever you need to. I'm gonna let it go. For now, the last one for this. I so wish we had that Nico Nikoni.
In time,
Emote.
we'll have.
Yeah,
The one that you showed the person who was doing live stream while drawing on.
yeah. His one was really
yeah,
cool.
that plugin was so awesome. I would
Yeah.
like to have that.
There's this really amazing artist from Japan. His name is Neg Illustrate, NEG, and he often does live streams, and he has really good live stream setup going on.
Yeah, a really fresh and different sort of live stream setup.
Yeah, we're gonna be doing something like that soon, and we're also gonna add emotes and stuff like that for our live streams.
Okay, after this we have to place some spacers. I have freshly 3D printed some spacers. I'm gonna bring them. We're gonna put some spacers, and I think on top of that we'll add bearings once again. So there's gonna be a double layer of bearings. This one is here. I'm gonna bring the spacers.
For both of the actuators, Ali, once you have only one actuator for each size remaining, I want you to record that separately for a video.
Once we have
Only one actuator for each of the motor remaining. So one for the M6C12 and one for the 5010 motor. We're gonna have to record that separately video. Yatta, so finally we have one encoder done and ready, and we're gonna have to do this for all of these now. But we were using a different gauge wire, and now that I've gotten the hang of it, it's gonna take less time for me to solder these.
Okay, so I'm gonna be adding spacers one by one. First of all, we'll make sure the bearings are pressed in nicely.
It looks really pretty, right?
Yeah.
The whole thing is gonna look really cool once it's
Yeah, but
assembled.
once it has the BLDC motor and the actuator is complete, it's gonna look really cool. spacer added. This one, the 3D printer is printing more spacers. I'm gonna be adding them as they are printed. Okay. Some of them have different size. I don't know how much that's gonna affect the final assembly, but some spacers have a slightly different height compared with the other ones. The fourth one, alright, I'll just wait for the remaining spacers to be printed, and then we're gonna add bearings on top of it once again. In the meantime, there's going to be a slightly, I'm not sure if it's a different bearing or the same size bearing which needs to go in the center. Let me check. Oh, it's the same one. It's the same size. Okay.
The color is slightly different.
I mean, it doesn't really matter. We also
Yeah, we
have the blue one.
Yeah, we have the blue ones
But
here.
it's okay. It doesn't really matter. 1, 2, 3. 1, 2, 3, 4
Nothing
spacers.
really matters.
Yes.
Anyone can see. Nothing really matters. There's a really good UFC card this weekend.
Yep. Alex Pereira.
Poton.
Poatan.
And there's Mirab as well. There was this one artist on Instagram. He made such a cool artwork for the
UFC?
yeah. So the UFC, they they don't lean that much in advertising. They have the same sort of bland advertisement for all of their cards now. But some fans, they make these really amazing artworks in order to promote the UFC cards, and UFC shared one of those artworks on there. Let me try to find that if I can. I really wish UFC commissions more of these artworks for their fights. It helps the artists, and they look really sick, to be honest, compared to their regular, like just two people facing off each other. So yeah, this is the artwork I'm talking about. Shout out to this artist, man. This is so sick.
Nice. Yes, it is pretty decent. Nice.
We need to have more of these. Right now their marketing and promotion is pretty much the same, and it's, to be honest, it's gotten really bland for all of their cards. They have that same sort of template, and they just slap on the PNGs of the fighters facing off each other, and they apply this stupid sort of yellowish or sometimes gray gradient on those images. It looks really bland and really dumb. And also they do the same for the marketing video, you know, the video that plays before fights or before the main event starts. It's always the same. The editing is same, the pacing, the music, everything is same, and it's gotten so boring and repetitive. I don't know if they do that to save money. Most probably to do that, but they need to bring in some fresh talent, some new artists like the ones I've showed you. So that way each card is gonna have a really fresh look, and each card is gonna be memorable.
This looks so cool.
Yeah.
The parts are coming together pretty neatly. Adding it to this one.
I think I'm gonna cut down the wires to get them the right size first of all, and then I'm gonna start soldering them, because it's like taking a while to solder just a single wire.
Neat, pretty neat. So we're gonna pick this part, this small part, and we're gonna insert both of these onto this part. We're gonna mount them on this small little part over here. Right, the tolerance is pretty tight.
The tolerance for what?
For inserting these two parts together.
Ah, gotcha. So these are the parts that will place a 180-degree offset.
Yeah, oh, yeah, it went in. It sort of snapped in.
Snap fit is such a satisfying
Check
feeling.
this.
Yep, it's slightly off center.
Yeah, nice. And now the other one needs to snap fit on top of it here. So let's do that as well. Snap fitted once again, very easily. And now we have this off center sort of rotation for both of these. Nice. Let's carry on. So like I need the spacers for this part, otherwise I cannot add the bearings, and it looks like they just the 3D printing just got finished, so I'm gonna bring some spacers, add them to this part, and then we can continue the assembly.
Yeah, it looks so trippy. Yeah, but these are at a slight offset. Their center is not the same, and while putting them in the actuators, we have to place them at a 180-degree offset like this. So it needs to be like this when going in. Yeah, and it's such a cool design.
I think I need to put the spacers for print once again. Our 3D printer seems to have a beef with that. It doesn't
Yeah,
like
we've been using our 3D printer for such a long time in this lab, and the bed adhesion has really started to drop off. And it's just something you have to mess around a lot with when you 3D print a lot of parts. But recently we have been using our 3D printer for a lot of different things. Let me grab one I showed in the last live stream. Just a second. So this is sort of an action figure we printed recently and hand painted it using acrylics. I'm gonna have a video tutorial on this coming out in a few days as well. There are a few electronics in this unit, and it's mounted on this plate that can rotate when you switch it on. So there is a potentiometer over here. As you can see, you can control the speed of rotation, and when you put it on your desk or table or whatever, it rotates. And also this display over here, you can fetch anything, any public information from the internet, and you can display it over here, and it updates in real time. So it's connected to the Wi-Fi. It looks for the data on the internet in real time, and it updates that data on this display. So this display refreshes every few seconds. And then we have a knob over here to control the speed, and the rest of the electronics we have inside of this box over here. It's really lightweight. The entire thing is 3D printed and painted, like I mentioned. It's about, I would say, 600 to 700 grams in weight. So it's really lightweight. And I sort of went for metallic sort of finish with this, but you can also, there's a lot of flexibility when doing acrylic paints. You can sort of choose the finish you want. This black over here, it's jet black, but I think a matte black would have looked much better, but I didn't have those on in my acrylic set. So with the bed adhesion issue, the 3D printer we're using, it's more than a year old at this point. And if you use your 3D printer that much, the bed adhesion, it tends to become an issue, definitely. I've had some people recommend to me to wash my 3D printer bed with soap water, and I don't know about anything about that. I haven't looked it up on the internet, but it sounded a bit suspicious, so to say. But yeah, if your 3D printing is regularly causing issues, I just recommend grabbing a new printing bed, because if you're printing a lot of parts from your lab, and especially if you're running a 3D printing warehouse, it's a really good business model for these days. If you haven't looked into it, you can look at it online, but if you're doing any sort of that thing, you might need to consider your production time and a little bit investment on a new 3D printing bed plate for your 3D printer. It can go a long way. This is the encoder we're working with. These are the resistors we removed from the encoder in our last live stream. I have uploaded a video on how to remove SMD components by using a simple soldering iron from your lab. these are the SMD components we removed in the last live stream, and using a normal soldering iron, you really need to know the technique on how to do that, otherwise it's going to be really difficult to do if you don't know what you're doing. But if you have a proper heating nozzle and a proper SMD soldering station, all the power to you. You can easily do that if you have access to that stuff. But if you just have a simple soldering iron like me, you can go and watch the video on my YouTube channel, and there I tell you the trick to do SMD soldering with small resistors really easily. Both soldering the resistors and desoldering the resistors. A lot of it is just honestly repetitive work, and if you don't have access to the right materials, like in my case, it takes way longer to sort of hop around the tolerances of the wires. Like in my case, I am having to prepare all of these wires before moving on to the soldering phase. So yeah, that's why we're mentioning it again and again, to make sure you look at the bill of materials. There are a lot of things that are not mentioned in there. If you guys look at the tutorials or look at the videos, especially 24 gauge wire is not mentioned in there, but you really need that in order to build this robot. And if you miss it somehow, you're gonna have to spend a lot of time preparing these wires like me. Thankfully, we had close to that 20 gauge lying around in our lab.
The spacers are so small that are 3D printed. The preparation time is more than printing. It's like 90% of the time or 95% of the time is just for preparation, and the rest 5% is for the spacers.
Yeah.
It's just taking time to prepare.
Yeah, 3D printing technology has come so far these past few years, and it has really gone mainstream all of a sudden. Like a few years ago even, they were not that common. And most of the time when people needed 3D printers in like university especially, most professors and students, they were like trying to build their own 3D printer, because commercial 3D printers were really difficult to buy or get your hands on, or they were really expensive. But Bamboo Lab has really, like, it started off, Bamboo Labs started off as a Kickstarter project, I think, and they have really like revolutionized the whole 3D printing space.
There's other companies as well, like Bamboo Labs, and then this Prusa is pretty good as well. So like they also have a huge R&D team that's just working on new upcoming technologies for 3D printers. They're moving at a pretty good pace. Even 3D printing technology itself will be very different in a couple of years. It's evolving.
Yeah, there are people building houses using 3D printers, and there's this one startup, I think it was called Rocket Lab, I might be wrong, but they built in their entire rockets using 3D print technology. So they have this whole warehouse sized 3D printer in their facility. They have built it themselves, and once they've built that, all of their rockets, I think it takes them only a few days to make an entire rocket using that 3D printer. and they've done some really cool tests on those rockets as well. So yeah, the 3D printing technology, it really has come a long way.
Yep. Alright, one last spacer to go. Till then we can keep inserting the brass inserts on this other actuator part I have.
Didn't we print these spacers in advance?
Our printer is not very good at printing them, so like the adhesion is not very good. So if I print like maybe 5 or 10, sometimes I don't get any, sometimes I get 2 or 3 very good. So it's just sort of an iteration game.
Yeah, I think
That's
at this
one
point
of-
we need to consider buying a new 3D print bed.
Yeah, for sure. The adhesion on this one is it's really not very good.
These brass nuts are really difficult to get at hardware store. So I think depending upon where you're living, you really need to order them online. And they also might take like a day or two to if you have access to them nearby somewhere, it's gonna take a day or two for them to ship to your house, so make sure to also order them if you're planning on building this robot, because they are not generally available on hardware stores, especially like custom sizes like they are using in this robot design. The video is gonna get slightly more exciting towards the end of the live stream when we have this actuator ready.
Yeah.
Yeah, but the first one, it's taking some time, and also because we are printing these spacers meanwhile on the 3D printer, it's taking a while.
I do have a lot of spacers printed for. Oh, by the way, I might have some spare spacers. I just recalled.
Yeah, I swear we printed them
Yeah, we
earlier
do
on.
print it. I was thinking they were different for the M6 C12 actuator and for the 5010 actuator, but I think this part is the same for both.
Yeah,
of
I
them.
think they're the same.
Yeah, I do have some laying over there. I'll just bring them in a moment. Let me just quickly insert these ones first of all. This part. I think once these two actuators are done, the shoulder of the humanoid would be sort of we can attach it to with the aluminum profile once these two actuators are
Yeah,
done.
there are a lot of aluminum profiles, and we ordered them from China, and they came out the exact size that was required. So I think pretty much wherever you are living in the world, you should be able to find these from local, not exactly hardware stores, but if you have like stores related to microcontrollers and stuff like that, you should be able to find these from there as well. And you need an aluminum disc to cut these if you have a machine in your lab. Otherwise you can just order the exact sizes from China, and yeah, like you're seeing over here, they're pretty efficient with the sizes, and the delivery was really quick.
Oh, it's like we do have a large number of spacers over here, which we printed earlier. Just gonna open this from here. These ones. So that's a relief. I'm just gonna use these now. There's different ones for M6C12 actuator and 5010 actuator. So for now I need these ones. So I'm gonna use these. They're also pretty good size.
Yeah, so the timeline for the actuator design just kind of sped up.
Yeah.
We have these parts ready. We just need to put one more bearing and then we should be able to place the motor in there.
Yep.
It's like a Beyblade.
Yeah. Off balance Beyblade. Alright, this one is cool. So I'm just gonna put the bearing on top of this one, and this is the last bearing for this part. Yeah, there we go. The part itself looks pretty cool. So we're gonna start assembling this now. I think it somehow needs to go inside of this, like
You need to, yeah, that's before placing the motor here.
Yep, like that. Alright, we're gonna require some screws at this point. So for the M6C12 actuator, we have M3X55, M3X30. Do we have M3X30?
Yeah, most probably. If you can grab the vernier from there. Sorry. And I think these are yeah, these are, I think, M30. You can check them.
These are 25.
And what about, yeah, these should be 30 then. 30.
Yep.
And also measure the diameter from there. This should be M3.
This one is roughly 30. Yep, M3. 29.1 mm, so that's M3. Vernier caliper, M3X30.
If we had the correct wire size, 24 gauge, all the encoder soldering would have been done, pretty much done by this time. But I'm having to prepare all of these wires because we did not had the 24 gauge wire.
We're gonna pick up this part and place it like this. This is gonna be a tough one. So first of all, we need to insert this from here.
I'm almost done with the black wires, and after that the yellow ones are the last ones. After that we can just solder them out one by one. We can finish the job quickly after this. Otherwise, preparing each wire individually, it was a tough job to do. And we need to get this humanoid to prepare the wires for us and solder them for us. There's your one job for the humanoid. Yeah, that's why you need to build this humanoid, so you don't have to do all the prep work, prepare everything, then solder the wire to make the humanoid. You can just make one humanoid, and he, she, it, whatever you wanna call your humanoid, they should prepare the next humanoid for you. There's a Shark Tank idea for you. Okay, last one. The yellow wires. I'm gonna start preparing them now. Let's go.
I forgot which one was the 31. This one? This one, right?
Yeah, most definitely this one.
Compare these two. Okay. Yeah, this one is 25. Put it back here. We need this one.
Here.
Alright. Next one. Next up, this one.
Which motor is this one for? The one actuator you're making? Is this for the 5010 or
No,
the?
it's for the M6C12, the bigger one.
Okay.
6010.
So we're gonna get to see the bigger actuator first time around. Oh, I messed this up a bit. I'm gonna have to recut everything. Yeah, honestly, I would love a wire preparing and soldering robot. I'm already sold on the idea. Like if someone comes and pitches me this idea, I'm gonna say shut up and take my money. Come to think of it, it's a really mundane job as well. Like it's not fun to like.
Yeah, I mean it's just repetitive and laborious work. There's no like problem solving or applying of your brain. It's just repetitive work, wiring, soldering, and joining all of the parts. It just takes like a few hours or a few days repetitive work to assemble all of this. This one.
Once the humanoid is done, we can consider giving it some vision capabilities as well, because a lot of LLMs and AI models are getting really good in terms of decision making. Once they have an image reference or they kind of can see their environment visibly.
Snap. That's so cool.
So satisfying. I think yeah, they will go in brass nuts on the
Yep.
opposite ends.
Like now I'll have to just. Do we have the L key?
Yeah,
M3
on top of that pegboard over there. So almost done with this thing, and it's so like mesmerizing in a weird way. They're not exactly at a 180-degree offset, I think. Almost there. So there's almost a 180-degree offset in between these two. It needs to be, ideally it needs to be exactly 180 degrees. We're gonna double check that.
Okay, this one's too big for it. And this one 2.5.
I'm almost done with preparing these wires, and after that soldering them onto these encoders over here should be relatively quick task. Yeah, imagine if we try to fit a 14 gauge wire onto these encoders. It's gonna be it's probably gonna be impossible. I don't think you can even do that. If you like really pick a fight with it, you might be able to do it, but at that point you're probably insane if you try to do that.
Oh, it came out a little bit from the other side.
Interesting.
I can maybe.
I think then we need
it back a little bit. Yeah, we don't need to go maybe all of the way.
Yeah, the brass
nuts.
The brass nut on the opposite, and even if it's slightly in there, it's gonna hold the.
Yeah, it's gonna hold the product, but we don't know about the tolerance of the actuator. So like how tight these joints need to be, but we can always retighten them.
Yeah, we can always modify them later on if they're not
never needed. Okay, this one is also done.
2 more wires to go. Finally, then I think I'm done preparing the wires for now. We're gonna try to get them in as many encoders as we can. There's also one more thing that's really important you need to keep in mind. All of these motor encoders that came with the bill of materials, they do come with a magnet, and there's a magnet in each encoder pack. Now this magnet that comes with these encoders, it's a different magnet. It's not the magnet you can buy off shelf or some other round magnet like that. So an example would be these magnets that you are seeing. Let me try to grab one if I can. They're really magnety. Yeah. So this one, for example, yeah. So all of the encoders come with these magnets, and these magnets are not the regular off the shelf magnet. The axis at which these are magnetized is different from your traditional magnets. So you need to use these magnets with these encoders. If you try to use different magnets, I have a lot of magnets in my lab, but if I were to use separate magnets for this task, I would probably fail at that. So yeah, you need to save these magnets when you open up those encoders, and these are the magnets you should be using with the encoders. Okay, let's start soldering. Finally we're done preparing the wires, the stupid wires.
That was a while.
Yeah.
That took a while.
Okay, so blue wire for the SCL channel. Yep, so it's, even though I've prepared all the wires, it takes some effort for them to like pass through, because this is a thicker gauge than what these encoders are designed for, but we can make it work.
Alright, this part we have inserted all of the screws in this one, so it's compact and it's together. So now we're gonna move on to the other parts and continue assembling.
Yeah, so while when you're soldering these components, I definitely recommend using around a 40-watt solder. But for the more finer edges or parts, we need you can use a solder with a really tiny or narrow tip, like the 15-watt one.
Snap this in just like that, and on the other side we need to enter this part. Check this.
Last one for the second encoder. So yeah, now that I've prepared these components in advance, the process is much more quicker. But it was gonna be quick to begin with if we had the right parts. So once again, I definitely recommend you grabbing that 24 gauge wire too when ordering everything.
Snap fits are so cool when the tolerances are tight. Okay, so this is good. We have one bearing on this side and we have the other one on this side, and this part is compact and together. Let's bring in the next parts for this actuator. This is right here.
Okay, another one bites the dust. So we have VCC attached, we have the ground attached, and then we have the wires for SCL and SDA attached.
Interesting. So what done is they are picking up one of these. Alright, this part we're gonna insert it inside over here from this point, and we have to make sure this is aligned though, that's very important. So just do it like this and then just snap fit all of this.
Yeah, there's a bottom part as well you need to insert from the other end. Make sure to align that as well. This strip is really oxidized, it's like really messed up. I need to change that, or I need to clean it later. It's like not leaving the solder where it's supposed to drop off, it's picking up the solder. But I'm in a bit of a hurry, so we're gonna have to deal with this in whatever way we can. Now we're gonna grab a black wire and we're gonna use it for ground. We're gonna stay with the tradition and the coloring scheme in electronics, and let's solder it over here. Kind of messed it up. It's just rotating freely, which is like so messed up. It's not supposed to do this. So the red and black wires are in place for this encoder. Now to move on to SEL and SDA wires. Are the parts aligned yet on the encoder?
On the actuator,
Yeah, actuator, sorry.
there's one part I'm having slight difficulty with that I'm looking at. It's supposed to go in and fit fully, but there's some.
Yeah, I
Very
think
subtle gap.
yeah, you need to push it more on the bearing, I think.
Yeah, it could be. Could be.
Because everything needs to be like really tight together.
Yep.
There are a lot of different bearings too. I think there might be this bearing might not be the right width.
No, I think that this is a correct one. The bearing is correct. However, there's some very subtle issue with the tolerance of this part.
Okay. I think you need to you need to really press it and try to push it in then.
Yeah, I think that that could be one of the issues. Like that. Make sure everything is snugged in tightly, tight and nice. This part for some reason is not fitting very well on this. We want to add a bearing over here.
Yeah, so I have another encoder ready over here. The soldering is not the perfect because the wires are not the correct size for this encoder, but we're having to work with this somehow. It's like really difficult to fit thicker gauge wires into like thinner spaces, and that's what I'm having to deal with right now. Red goes in VCC, and I'm gonna have to hold it in place over here and apply the solder wire. Actually, I could really use a double tape here, like I was using yesterday. It really helps to keep the, if you don't have a soldering station or a soldering stand, the double-sided tape, it really helps to keep everything held together while you apply the solder. I'm gonna add some over here. After I apply this little bit of solder over here for this voltage wire. Where's the double-sided tape?
I'm not sure.
Here you go. Now we need to find the scissors. I'm gonna use this double-sided tape to keep everything together in order to solder it.
By the way, update on the actuator. I'm having slight difficulty adjusting this part to snug in tightly with this part like this one has. So like I need to remove this space, but for some reason I am unable to. So I'll see where this issue is coming from. Tolerance is not as tight as it's supposed to be.
I think you just need to press really tightly. I think it's just one of those you need to apply a lot of strength, sort of. Yep, this should this double-sided tape, it should make the process easy and relatively quick. Let's see. This is the first test, and I'm already having a good feeling about it. Yep, it really helps with the soldering process. These SEL and SDA holes are really close together, so you need to be careful when soldering these as not to mix the two wires, or you need to make sure the wires are not loose so they don't bump into each other when the encoder is moving around. So yeah, make sure to be extra careful when soldering these connections.
Can you take a look at this part?
Yep, give me a second. Show it to me. Is this even the right bearing?
Yeah, the bearing is correct, but I think the issue is with this part over here. So like if you can see this video, check this video. So this is the part so far, you can see, right?
Yeah.
Now he's going to insert the bearing on this part, okay, and you can see that it sort of goes half in, like that. Now insert this bearing on this one. It doesn't go in, right?
Yeah, it's
This
in
is like-
already. It's in there.
No, it's not like you can still see the gap, right? But in their case, there's no gap.
Then it's a bearing issue.
Can you pick another one?
Yeah. Let's try this one.
The bearing is supposed to go in. The reason why is it's unable to is because there's some deformity over here.
So do all of those parts have these going on over there, like this support sort of thing? Check the other parts.
This one. Oh,
This is not the right part, I guess. No, it's not the right part.
it's this one. It's this one. I think this one's even. This one's even more deformed as compared.
Yeah. In that case, I think all the parts come out with this deformity, and we do have to
But
deal with
how
it
much
as
do we have to like address it? I'm not sure if like the bearing.
Yeah, do we have to like cut it entirely? This deformity, or like is there any extra edge even in the design?
It's not even too much. I don't see why the bearing doesn't fit in.
I mean, it's pretty much hitting over there. That's what's causing the limitation.
I mean,
see.
then it's supposed to be perfect.
No, I think it was the part of the supports and it needs to be removed. I think so.
Which part?
Yeah, this extra, this
No,
whole ring.
I don't think so. You can see it's on here as well. Like this is the standard part. It's not part of the support. And I think so. This is the other part. It's tightly snugged in.
Yeah, make sure to keep it at 180-degree angle before pushing it in.
Bummer, really. I think in the worst case, this one is just gonna be slightly open. It's not gonna be fully closed. Let's see.
Yeah, we need to like see and address this issue.
Yeah, I think in the worst case, our actuator is just gonna look like this, like this. It's not gonna be like fully snugged in.
Let me check. Let
Even this is a separate issue. Check this. Check this video over here. So like now.
Yeah, the bearing should be flush with the design, right?
The bearing as well as this part is supposed to be flush with the design. Check here. Check here. So, all right. This is the side. This is the side. Okay. And it has bearing on it. Okay. It has the bearing on it.
Yeah.
Now, once he pushes this, it just snugs in tightly, whereas our part does not. So,
It's just like
an elastic sort of part.
yeah, like you just need to apply a lot of force. Let me try and do this.
Oh, let me do that. This one is.
So
Okay.
another encoder has been soldered.
Now you can
Because of the wrong wires, it was taking like a long time.
just try that. It covers all of the bases.
Yeah, so we are having some tolerance issue with the 3D printed part. It's supposed to fit right in, but for some reason it's not going in there. Like it's gonna break at this point if I apply some more force to it. We're gonna look into this issue, but once this gets snugged in there and sits nicely and perfectly, one actuator is gonna be done. So this is like what one actuator for this robot will look like.
Alright, we're gonna come back to this in a moment. For now, I am going to connect the BLDC motor with this part. So let's start with the motor. If you can place it over there. The BLDC motor. Here we go. Alright, we're gonna start attaching this with our part right here. The motor goes inside.
Yeah,
of this
we need to add a drum roll emote for whenever we're revealing new things or we're unboxing
okay.
something. But this is pretty much what powers all the joints of the robot. So it's a really powerful and precise piece of technology, and it's gonna be present in all the joints of the robot. This is what's gonna move the elbows, the shoulder, all the joints in the robot. And yeah, we're gonna assemble this now. Once this is assembled, these encoders, they go on there like this, and then we connect it to the motor drivers over here, and after that one robot joint is ready to be moved. We just need to give signals to these using microcontroller or our PC. We can connect it directly to our PC using the USB CAN bus. You can simply plug in the USB cable to your computer, and you just need to attach this motor controller via wires. These 4 encoder wires, they are gonna go on here, and then we're gonna be able to rotate and control this joint. And it's the same for all the joints. There are 2 different sized motors. This is the bigger one, but there are 2 different motors used throughout the robot, and the process of joining those motors, these controllers, this encoder, everything is same for all the joints. So once you have done it for single joint, it's a repetitive process, and you have to go through all of the joints in order to build the entire robot.
Can I get the scissors versus scissor?
I don't have. You can use this nail cutter to open. I'm not able to find the scissors.
Pretty interesting hacker helps we have over here.
Yeah, nail cutter is like a real lifesaver. Let me know in the comments if you've ever used nail cutter during soldering. I'm pretty sure 90% of people who've done soldering have used a nail cutter at some point to cut the wires.
By the way, we have seen some improvement in views from our last live stream, and
Yeah.
it's a significant bump. A significant.
Yep.
I can't imagine if we keep doing this for a year. Let's just say, along while we're working on.
Yeah, and we need to add a few different camera angles, like we discussed in the last live stream. We need to add a lot of camera angles and emotes, and yeah, some interesting things and some interactive things that people can do when joined with this live stream.
Alright, there's a lot of parts came with this BLDC motor. So once again, this is the motor that we're going to be using to build the actuator. So I need 4, 1, 2, 3.
I'm gonna grab the
4.
blue wire. Yeah, we have the blue wire over here, and let's connect it to the SCL, and just put it nicely on this double-sided tape over here, and solder it while the wire is exposed on the other end.
Alright, there is these small ones. These are the long ones. I'm pretty sure of that. These are the long ones. And then we have not these, I think these are the short ones.
Can I have the nail cutter?
Just a minute. The rest of the parts for now we can place them back inside of here. By the way, Hassan, this BLDC motor came with its own heat shrinkers.
Ah, interesting.
So like they have.
Yeah, I wonder where we need to apply those
here in these three. There's three.
When making these connections, okay.
Yeah, when making these connections with the connectors that we bought from Amazon.
Okay, gotcha. Yeah, for these connections you really need to go in there and make sure to apply a lot of solder so these wires don't move around. Otherwise it's not gonna be a good idea to get these wires shorted together while the robot is operating.
They've already attached the magnet with the glue over here.
Yeah, you need to no, so the process of attaching the magnet on this motor is different than 5010. Yeah, so you need to double check that. Yeah, I think they told us to apply it, put it directly on top of the tip, but you need to double check that.
Okay. I'm wondering, is it possible to add it afterwards?
Yeah, I think so. It should be possible.
Yeah, let me just connect this now for now. We can unscrew it later on. Okay. Just making connections. Just making connections. Screws and nuts. Alright, that's one.
Nuts and bolts. Just a lot of nuts and bolts. Yeah, these wires are causing a lot of trouble because they're not the right size. So yeah, make sure to order the right size wires if you're thinking of building this thing. Otherwise you're gonna waste a lot of time trying to get other sized wires in these connectors. The holes in this PCB are definitely made for like 24 gauge wire and nothing thicker than that. It's already like a long process, but it's taking extra time to make things work with these tools that we have available. I think the audio this time around should be much better compared to last time. In our first live stream, the audio was really messed up.
Yeah, we'll need to check that.
Yeah.
Today's audio as well afterwards, because last time it was not good at all. If the audio is good this time, that's one step for us. Like improvement one by one step at a time. There's still so much we can add. Camera angles, in terms of camera angles, music, and
yeah, shout out to the guys who watched the last live stream, because I bet it was really difficult to watch. Like people joined the live stream and there was just like whispering going on, like, okay, if we're working on this right now. Yeah, this audio quality for that live stream was really poor. So shout out to you guys who watched that. If you're not like willing to watch the entire like last part, the basic summary of that I have just attached in a video which is named soldering and desoldering SMD components, and yeah, basically I've explained the technique of doing that by using a simple soldering iron that I'm using right now. There is a trick to it, and if you know that, if the SMD components are reasonably small, you can simply solder them and desolder them using a simple soldering iron, and once you understand the trick, the process is really fast. It's like a 3-minute video, and after that you should be able to do that by using a normal soldering iron inside your lab.
added this. I think we're gonna hit 30 views very soon, and that's totally unexpected
Yeah,
for a second live stream.
yeah, let's call it a day when we hit that. But yeah, a lot of people joined us for the humanoid building during this live stream, and in the next one we're gonna try to add more camera angles. We're trying to source some cameras. Maybe we're gonna add them using our mobile cameras, or maybe we're gonna have to order some new cameras to attach to the computer we're streaming from, and I'm gonna try my best to add some emotes and custom reactions as well in the next one. Let's try and make those 2 steps for the next live stream.
Yep.
So if you can see over here, I have prepared 6 encoders. Here you go. I know they look like a mess right now, but yeah, this is what a single encoder looks like when soldered, and I have 6 of these over here. We have to do 22 in total, so that's gonna be the soldering part for today. And probably before the next live stream video, all the actuators are gonna be assembled if we don't run into any 3D printing tolerances issues, which if that happens, it's gonna be a really long time trying to 3D print these parts again with the proper tolerances. But let's hope we're able to fit everything together in with the 3D printed parts we have right now. Okay, the black wire for the ground. Yeah, we need to also add a copyright free lo-fi sort of music in the background, because now that I think of it, the stream without a slight backdrop of music, it sounds really boring, because it's just ambient noise and this voice of the like solder moving around and different components and screws jingling. That's like an ambient noise in its own regard, but it's not like a fun one, if that makes sense.
I have an interesting idea. So like the next time we're gonna add some music, there's probably gonna be some camera angles as well, or plugins that we're gonna add. But we'll write a header over here. What's your dream? Or like some interesting question that the chat can reply
Yeah,
to.
we can have like a question of the day.
What would you like to build, or what's your dream?
Yeah,
or
like
something
simply,
like that.
what would you have this humanoid do?
Yeah.
If you're listening to this live stream, or if you're following along up till this point, just answer what would you have this humanoid do. Like I would definitely have this robot if I can solder these wires for me and prepare. If the gauge of the wires are wrong, I would have the humanoid handle all of that stuff. Interesting times ahead. I can definitely see a humanoid doing a live stream as well. I wonder how people would respond to that. Like, would you guys want to see a humanoid doing live stream? What are the questions you would ask that robot? Because the answer probably would be like the collective sum of the information available on the internet, because that's what most LLMs are. But if maybe a humanoid playing Roblox or Fortnite, we can maybe make that happen sometime in the future.
Like we have a slight problem over here. I'm gonna try and fix that. The supports, it seems like they were not completely removed, and the motor is BLDC motor is not aligning well with the 3D printed part. So just building one actuator is taking some time. It's taking a lot of time.
Yeah, but it's like the first actuator we're building.
Yeah,
Once we figured out the ins and outs of it, and once we like successfully assemble one of it, the rest of them are gonna be like
yeah,
a
true.
breeze.
True.
Yeah, these wires we really need to not move them around a lot. This encoder, we need to make sure it's locked in place and it's tight. Otherwise these wires, they are really close together, and I'm like getting slightly scared. I don't want them to
Opening up the supports, the holes, they are pretty tight, and there is, due to that reason, this part is not fitting with the motor. So I'm just gonna open this up a bit more. I think we're gonna keep going for a while now until there's still easily time we can.
Yeah, definitely we can do this.
We can keep going.
Another one done. There are just a lot of components. It's a really decent design because it's really simple, but there are a lot of repetitive parts. There are a lot of repetitive things you have to do to put everything together, but at its very core, it's really simple. Once you understand how to solder properly with the motor controller, one encoder, you just have to, you can listen to music or you can listen to some podcast, you can watch a live stream like ours meanwhile, and you just have to repeat the same process for the rest of the components. It's exactly the same.
Alright, I'm gonna try this once again. Try to align the motor. See if it fits in. Alright. I know there are two screws which go here.
tomorrow we're gonna have the live stream. If we're gonna have the live stream, we're gonna have it slightly early because the day after tomorrow there's a UFC event and the timing is a bit messed up for us in Asia, so we're gonna have to adjust around that time. So the live stream might start a bit early tomorrow, but I think a lot of progress would be made between this live stream and the next one. We're gonna do a lot of this repetitive process of camera as well, just to make sure everything is going fast and smooth. So we're gonna have made slight bit of progress from where we leave off at the end of this live stream.
Yep. I don't really understand these the alignment of the holes in this actuator and this part. It's
I think
way off.
you can start with 5010 first.
It's way off. But I'm gonna have to come back at this some point. Might as well do it right now. But the alignment is off. How are the encoders coming along? Is
Yeah,
it like the
decent,
first
decent.
one?
It's not
First
the
one?
best soldering.
Oh, you've already done
Yeah,
it.
it's not the best soldering. It's like really messed up and really close together. But because this wire is
they can they have a chance of hitting each other.
no, I've tried to make sure it never happens, but yeah, there's nothing much we can do because this wire is thicker than the wire we needed to attach over here. But
Oh yeah, that's
yeah, because of the like short timeline and everything, we're gonna have to deal with this.
That's an issue. I think in the worst case I might have to use the drill to widen.
Why is the alignment off?
You can see for yourself, like 1, 2, 3, 4. These 4 are the ones that are supposed to go in it. But just try
a
to
second.
align the holes. They don't really align all 4 of them. Which is strange because this part was made. It's not even 3D printed bad. The quality is good. So the holes are theoretically supposed to align well, but they are not aligning. I'd have to widen them a little bit.
No, I think they're aligning okay.
Okay.
Yeah.
Or
Yeah, they're very slightly off, but the
if
thing.
you can try putting in these 4.
Yeah. So
These 4.
okay. Just a
putting
second. Let's try and put these holes through here to join the motor. Now you have to. Yeah, even at like a weird angle, they're not going in there.
Yeah.
But let me double check this if we are using the right holes. I think even if even if two of these holes can be aligned, it's like more than enough.
Yeah, but even that's difficult.
Yeah, I know it's a bit weird to say the least. Why is the alignment so off? Have you tried this with other parts? The other of these
Which
parts.
bearings are these? I think they're for the like 5010 actuator. Oh, got it. Because we have the 6010 actuator in Lex as well. Got it.
Yeah, the alignment for this thing is totally off. This 3D printed part is not sitting on this motor over here. Let me try and yeah, is there a chance we're supposed to use any other
BLDC motor?
no, not BLDC motor, any other holes or alignments?
So this one is 15. This one is clearly.
Let me check
This
for
one is-
that
I'm not gonna use this.
if we need to use any other holes. Yeah, I have found two that are aligning somewhat. No, they're not aligning well.
Where are
So
the
chat, right now we're trying to align these holes. There are, as you can see, there are a lot of holes on this motor, and they are supposed to align with this 3D printed part, but they're not aligning. And yeah, we're trying to figure out what's wrong with this design wise. Have these motors like changed their holes recently, or the placement of these holes, because this design is supposed to align with these, but it's not aligning, and that's what we're trying to figure out right now.
It's not too much of a gap. I think we can just drill a little bit.
Yeah,
and
but if we're gonna we'll have to do that for all the parts, and
yeah. We'll need to do for all the parts.
yeah, so can you grab another one of these from there,
Okay.
because there might be a chance that this is not for the right motor.
No, it's pretty much for this one. You can try this one. It does not have hex nuts yet, but you can try this one. Not aligning, right?
Yeah, same here.
Let's continue. I'll move on with one of the 5010 actuators, and
Yeah, I think we can do 5010 first, and then we can
we'll come back
come
to
back
this.
to this.
Come back to this.
Okay, CL wire is sitting there. We need to also do the SDA.
For this one, let me open up one 5010 BLDC motor.
and I'm gonna try to get in there, and I'm gonna try to put some on here. What's the notification from OBS Studio?
I think they're just random notifications.
The standard notification?
Yeah.
Okay.
Seems like a standard notification.
SCL's good, SDA is good even though this wire is rotating. I don't think, yeah, rotating wire is not a good idea. I need to like somehow attach it down there. How are we gonna do that? I'm gonna try to grab the nail cutter and I'm gonna try to chip it away from here, like slightly. Yeah, now we have some exposed wire to play with, and I'm gonna try to lock it in place with more solder wire. How about the alignment on the 5010 motors?
I'm looking at it. We will know in a moment. There's something I wanna try with this actuator. Like the mat component. I think there was a slight mistake that we were making.
So we were trying to do it upside down.
Yeah.
Okay. That explains
The whole issue. What a strange hardware debugging issue.
Yeah, I think it's gonna be like the same sort of issue with the bearing that's not snapping in the right place. Yeah, it's gonna be probably gonna be the same thing for that, because the tolerances for the design they're already for 3D printing, the tolerances they're already baked into the design, and I don't think we should be having those sorts of issues when joining everything together.
Yep, that was our bad.
And now I am gonna attach this ground wire. If the wires were thinner, they would have sat much better on these small tiny holes, but because these wires are bigger in size, they're jumping around a lot, So I'm having to solder them both from the upper side and the bottom side, so they don't jump around and they, yeah, don't eventually short themselves with each other. There are some repeat chatters joining us. They're not like exactly chatters but viewers. They join us every now and then, and the view count overall does not go up that much. Shout out to the repeat chatters.
Is this one here for now. Where did that part go? Okay. So we're gonna tighten this with screws now.
Yeah. While you're here, let us know what other sort of robotics and electronics content you guys would like to see. For now, these live streams are gonna be just about robotics, but I have some other ideas in mind for later as well. There are gonna be some animation live streams as well. I often do 2D frame by frame animation, and I'm gonna be doing some live streams about that as well. And then maybe sometimes we can also do 2D illustration live streams like Neg illustrates, because I often do 2D illustrations here and there. We can have a live stream centered around that as well. But for now, while we're building this robot, these live streams are gonna be centered around this project. It's only gonna be like a few days. It's gonna be probably less than a week. We're gonna be done with this.
Yeah.
And then we're gonna move on to other live streams and content. So yeah, if you have any opinions about the content, what sort of projects you guys are interested in watching. We also have made some action figures by using 3D printing, acrylic painting, and we have introduced electronics in them as well using microcontrollers. So we can make some cool miniature robots or anime characters using these electronics components as well. This is a motor controller we're going to be using. This motor controller is going to drive this motor that we are attaching for the joint of the robot.
Almost done.
In Japan, there's a trend of making anime characters with all the bells and whistles, with all the joints, all the axes of freedom, and they are based on servo motors, so they can move around, walk around by using joysticks, or if you train them for custom motions, they can also do that.
Yeah, I think they write policies for that. Very specific set of policies, for example, for punching or for a certain move. The code is written. It's kind of like a policy. It moves each actuator, each of the 27 or 28 servo motors which are inside of it, in accordance with that policy. So the code runs like a policy. Alright,
Yep.
this is attached. Okay, input shaft stiffener. M3x4x5 insert. Do we have it? M34x4x5 insert.
Yeah, the one we have, it's probably that size.
Which one?
M3x4x5.
This one?
No. The insert is this one.
No, not this one. I need the hex stand.
Yeah, then
M3x4x5.
you can check the size of this one.
M3.
I don't know what size it is specifically.
It's like M3. I'm gonna have to find M3 as well. It seems like it goes in.
So all these, yeah, it happens. Things like that happens all the time when you're building this robot.
Accidents in the
Yeah, it was a small explosion. Like there definitely was not a really big explosion or a potential short circuit with a battery over here. There definitely was not something like that. Yeah, so these are the encoders. They look like a mess right now, but yeah, that's how they're gonna look once you solder them as well. These are the ones we have soldered so far, and we have quite a few ways to go. We have yet to solder these as well.
M4.
And yeah, it's the same for every single actuator or joint on the robot. So you're gonna be doing this for every single joint in the robot if you're gonna be building one. Let's attach the ground one.
Do we have a smaller one than this? I don't think we have.
I think we got some new ones today.
See if we can find
Let me try and find some. Yeah, there were some round ones we got today. Yeah, these are all bearings as far as the eye can see, like so many bearings. Yeah,
Oh.
check these ones.
Interesting. I think these are the ones that we need. I think these are the ones that we need.
Let's load this one here.
One, two, three, 4, 5, 6, 7, 8, 9, 10. I got 10 of these. So let's see. Alright, it's a
It's
bit.
at the corner of the screen.
It's a bit loose. I don't think if this is going to be a problem.
In what terms is it?
It's a bit.
No, same. I don't think it's gonna be a problem. It's just there to, like a spacer. This part is gonna be attached using screws, right?
Yep.
Yep. So it's not gonna be an issue then.
the 4 slightly longer ones. This, and this, and this. These 4. One finger here, and we need to put this part over here. It's not exactly fitting inside of the motor.
Yep, so I think this one is locked in and ready as well. Couple more ways to go. Yeah, I think we're running out of
The wire?
yeah, no, not like wire, but the wires I have prepared.
Oh,
We are running out of those.
that's manageable.
Yeah, I will have to prepare a few more in a minute.
You'll have to
The next step I think is to
very
like solder
slightly-
all of these to the motor controller, and the points where we need to solder them onto the motor controller, they're really small. I'm gonna be double checking them in a minute. First, we need to make sure all the connections are okay.
add this over here.
Ground wire goes in there. We're gonna grab the solder, we're gonna apply a bit over here. So when soldering these wires on the encoder, it's a bit difficult to get them to get the solder connection to join the solder pads they have available on these copper parts available on these PCBs. But if you don't make the solder wire sit on there, the wire is gonna slip around when you move it, and it's gonna potentially make a short circuit when operating the device. So you need to make sure to sit the solder wire properly on that solder pads.
This is 5.38 mm. 5.38 mm, and the height is I think this one is M4X12. And I'm not sure if these are the ones that go inside of here. Like we will be needing M4X15, M4X15.
I think we have them, but we have.
and
Which ones
this is
are
also like-
these? If you can check these. I think these are M4X15. Yeah,
So
definitely.
like, what's the four? It's the inside one, right? It's the inside part. This one, right? Yep, I was right. This is M4. So like this is M4X. Once again, 12 to be precise. This is M4X12, and M4X12 is required on the 5010 actuator. I think yeah, I'll just put it back inside of here, and I'll pick a tape or something and I'll label this M4X12 so next time we remember.
You can grab that double-sided tape and you can only paste it on one side, and you can write with the marker on the other side.
Where is it?
Yeah, it's hanging over there, the white one. The white one. So just don't remove that white part, and you can write on it using a marker, a thick marker. You can use that board marker to write on it. I think it will work pretty well. I think the video we uploaded regarding SMD soldering, it's getting quite a few views. So I think a lot of the people that are viewing this live stream, I think they are from there. But it's gonna take a few days for that data to be available, and I'm gonna have to check if they are the returning viewers or if they are the new guys that are just passing by from that new video. Either way, this is the most views we've had in a live stream, and this is the second day of us doing this live stream. We're gonna be doing a lot more of these.
Yeah, there we go. Like I've labeled this. These are for 5010 actuators, M4X12. I'm not working on them just right now because I'm working on 6010 actuators at the moment. Probably in tomorrow's live stream, I'm gonna be working on 5010. Then we'll be needing these. So for now, I'm just gonna put them aside. And for the 6010 actuator, this one, in this part there needs a hex stand needs to go in. It's probably this one, but I'm just gonna confirm the size just to be sure. So yeah, let's see. So like in this one, there's supposed to be an M4X15. The length of this one is 15. Yep, it's 15. It's most likely an M4.
Yep, so back we go
Perfect.
to cutting these wires.
Perfect. This is in fact M4X15. This is exactly the part that needs to go in. Now they have mentioned in the video that some of these have slightly bigger sizes, some M4.
Yeah.
So you will need to drill the hole to make it slightly bigger. They have
Gotcha.
mentioned it, and it's not fitting in. So we'll need to drill this.
We can also like brute force it. We can maybe heat up the hex stand and try to
Yeah, that would be a
weld
good
it.
option. That would be a good option.
Yeah, but it would just lock it in place. It would fuse it, and it will be almost impossible to move it around.
We don't want that.
Then maybe yeah, we can just try and drill
We
it.
don't want that because for the magnets we might need to disassemble this entire thing.
Ah.
Like
Yeah,
tomorrow,
then let's just keep everything manageable and
yeah. So like tomorrow before starting on the 5010 actuators, I'm gonna first of all attach magnets to all of them with glue, and then we can sprint and attach all of the actuators. I think actuators, like assembling all of the actuators is a whole 1 day's job. It's easily gonna take that much time. And we're not even counting the legs and arms.
Yeah, it's gonna like take.
It's gonna be a while.
Yeah, and the thing is, we were already like running so short with the timeline we set for it. So yeah, I guess we can only try and focus on the upper body for this week too. And once we have that moving and that ready, we can think of the lower body later on, perhaps sometime in the future. It's like 5:02 a.m. over here. It's like getting really late.
Yeah, and it's getting a bit cold as well. Remember from our last winter in Japan, this time just before the sunset is when it gets
Sunrise.
sunrise. Sorry, yeah, is when it gets really cold.
Yeah.
The most cold throughout the night.
Yeah, this is like for some reason this time tends to be the most cold, and sometimes during the last winter we had to stay out during this time of the night, and it used to get really cold just before the sunrise for some reason.
Might need to just thicken this part a little bit.
We're also staying close to the ocean. I don't know how that exactly helps with heating up the weather or during the nighttime or cooling it, but it tends to get really cold over here either way. Okay, so I have a couple of more VCC wires ready and prepared. I'm going to try and solder them, hopefully.
This part is really thin for this hex stand. It's not really fitting into it at all. I'll need to widen this a little bit more.
We have the drill bit and the machine.
Where is it?
The drill bit is gonna be in here. Yeah, here we go. And the machine, yeah, we have the machine here as well. So we're gonna use this to widen the hole, because different manufacturers, they have different standards for these hex stands, especially the outer dia. It tends to be a lot different depending upon which manufacturer you get it from. So you're gonna have to drill the hole to widen it a bit. So there's gonna be some good old DIY engineering going on with the project as well, if you decide to build it. I am once again short on the ground wires as well, and I'm gonna have to just use this one for now. And after, I'm gonna have to prepare a lot more of these. Turn it at full speed.
No, I'm trying to be careful not to overdo this.
Uh-huh. Yeah, with these plastic parts, you have to be careful with not messing it too much, because it takes a long time for the, if you want to 3D print that part again, if you mess it up. So it's better to be careful and increase the width of the
Still not going
hole.
in, so
Yeah.
we're gonna open this up just a little bit more.
Yeah, it's like adding sugar to a coffee or a chai. You can always add more later on, but if you end up adding more of it, it's impossible to remove it from the cup. That was a weird analogy, but it works.
I'm gonna try this once more. Still not. Still not going in. There's a little more that we need to do. By the way, we've hit 40 views.
Yep.
That's crazy.
Yeah, I really wish we had that celebration emote.
Yeah.
But we're gonna try to add that in the next one. And yeah, this is the most views we've ever had in a live stream. And yeah, 40 in the second live stream. Pretty boring live stream, to be honest. It's not like it's just a bunch
not.
of soldering, and
It's not too flashy. Except for this part. This is flashy. So you know the the quote, I don't know which person exactly said that, but the quote goes like, as you start to walk on the path appears. Have you heard
yeah,
it?
yeah, yeah.
Like makes sense. So as you start making things sort of start becoming clear.
Yeah.
So like we know what are the next steps we need to do. Need to add music, need to add one or two more camera angles, and they just keep doing what we're doing, and the results somehow automatically show.
Yeah,
show
and
off.
and but yeah, we need to make it a bit more flashy, definitely.
Yep.
For sure.
Here's the bit more flashy part.
You know what would be really fun? You know, when we
A moment.
once we hit like around 1 lakh subscriber, I'm gonna have rooster fight on a live stream on my channel. Yeah. So working on some electronics, and then in between the interval or the short break, we're gonna have a rooster fight.
Where are you gonna arrange the roosters from?
They're like everywhere in the world. They're not like rare or special.
Do we have
Alright guys, so we are continuing on with this soldering and assembling of the actuators. We do have a hammer. I think it's somewhere over here. Yeah, there, I can see it. We do have a hammer in our lab as well. Yeah, there are like a lot of encoders, like 22. It takes like quite a while to solder them all.
Alright, I'm trying something pretty rash. I'll see if I can hammer this in here. I don't want to open the hole too wide.
Let me look at the hole first.
Yeah, I think it's pretty close. Like tolerance is pretty close. We'll see if it can be hammered in or not. It's almost there.
Like in terms of the board that you made with the machine.
Yep. It's almost just there. It's almost fitting in. Let's just a little bit more. This machine is so crazy.
Yeah, the way this machine sounds, it feels like it can make a board through the universe, like a dent in the universe.
Godzilla.
Like a black hole.
Godzilla tool.
It sounds really scary.
Pretty powerful. I think just widening this one hole has taken me around 25 minutes. It's taken me that long just to widen this one hole for this hex stand.
One more done. We have 9 more to go. We have 9 more encoders to solder. I think I should be able to do that in about 20 minutes. So in 20 minutes, we're gonna have all of our encoders soldered and ready to go. The other ends we're gonna have to solder to the motor controller though, and that's gonna take a while once again for all the motor encoders to all of the motor controllers. It's gonna be like this same time, 22 each. Is it going in?
It is, but it's not quite aligned.
Ah, okay.
That's an issue.
How do you plan to pulling it out?
It's easy. Like pulling out is easy, but the alignment is slightly off. I think because of the uneven drilling that we did.
I think you need to mute it to while it's like messing up. Yeah, sorry for that, guys. Probably someone got their eardrums busted up. Happens. We're giving you the real ASMR experience of being in a workshop. So regardless of wherever you are, you get the experience of being in a hardware and robotics workshop.
Oh man, so sometimes just one tiny component takes so much time. This one's still not going in. This time I'm just gonna fix the problem once and for all.
I need you to do something. Can you put the solder iron over here while it's kind of blocked because
Okay.
put the soldering iron over there while okay, now you can put it over here and let the wire through once it I'm trying to push it. Yeah, leave it. No, it's not. Melt it a bit more. It's not working. Okay, just leave it. It's getting really hot as well. Yeah, I'm gonna have to do something else. Try some other way. Yeah, I think the viewership has started to fall a bit off because
Just a moment, I'll be back. Just one second.
this is the time usually when, according to YouTube analytics, at least the people who watch this channel log off, and as expected during this time the viewership has slightly decreased a bit. But yeah, this is the most amount of views we've had on this channel while doing a live stream. Granted, this is our second live stream, and this is something we plan on continuing for the foreseeable future. We're gonna be working on a lot of interesting projects moving forward, and we're gonna be doing that in live stream format like we're doing right now. Now, if I am able to attach this wire through this hole, it's kind of clogged up. I don't know where this solder was applied, but it has kind of messed up the entire circuit over here. So we have to open up this. Yeah, I think I'll have to remove the solder from this section like this. Yeah, so depending upon the use cases or depending upon what exactly you are doing, you might need to switch between the 15 watt solder and the like 40 or 50 watt solder. It really makes a lot of difference when you're trying to do different tasks. For example, if you want to remove the solder wire from the component, a higher voltage solder would be much more efficient in doing that. You might have to try to apply a lot of heat to remove the solder wire, and a lower voltage solder is not going to be really efficient in doing that. I'm having trouble here with a 40 watt solder, and so you can get the idea with what we would have been able to do with the 15 watt solder. It was going to be really difficult to remove that, but I have removed the solder from that hole now, if it's visible. And now I'm gonna push the signal wire through there, and I'm gonna solder it on the other end. Let me put it over here, and I'm gonna apply the solder quickly so it snaps onto that wire and doesn't let it go. I am gonna try the other side now. Yep, it seems locked in, but I'm just gonna apply a little bit here just to be safe as well. Let me try and find a really good angle. This one seems good, and let's drop a bit of solder wire over here, deep in there, somewhere there. Yep, it's there. Now for the last wire, let's try and get this yellow wire in there. Okay, another one done. It's a good idea to also apply solder on the bottom side of these encoders so that the wire gets that extra grip and it does not move around a lot during the operation, because if it moves around and you get some short connections, it is gonna mess up the project And when you work so hard in a project, when you spend so much time building the project, it's a good idea to take that extra step just to add a bit of more safety to the design. Because this encoder, if these wires are gonna be jumping around a lot during assembly, and we don't want these wires to get short on the other end, because as you can see these ends are pretty close together. So we need to be sure these wires don't end up getting in contact with each other no matter what happens. So it's a good idea to make sure they are soldered in place correctly. So far we have successfully soldered these many encoders, and we have 8 more to go. Yeah, so we have 8 more to go, and then we have to solder all the encoders that we've soldered so far. We have to solder them here to the motor controller. We're gonna have to bring those signal wires over here to solder them on here. So here we have some, as you can see, we have some points. They are really narrow points, and it's really difficult to get in there in these areas and solder it. That's why I have this soldering iron which has a really narrow tip. That's what I'm gonna use to solder these signal wires over here. But it's gonna be a really tough job, and we're gonna have to do it for all 22 motor controllers and encoders. We're probably gonna be doing that later today as well, so when we come back for the next live stream, it's probably gonna be done. We're gonna be moving on to the controlling the motor during our next live stream session. This one is done. Where are the black wires? I did prepare a lot of black wires early on. Have I used all of the black wires? I'm not sure. I think we're gonna have to go to Akihabara or maybe Conan today, and we're gonna have to get more of these signal wires, because they're almost we've ran out of them. It's like 5:34 over here in the morning, and I think Conan opens at 6 if I'm not wrong, right?
Yep, at 6
Wow, that's like so quick even for like Japan standards. 6 in the morning. Moshiroi ne. Yeah, because I think a lot of construction workers and a lot of like hardware people, they start their jobs here at like right during this morning time in Japan. So in Kombinis, it's really crowded during like even at 4 a.m. in the morning, 5 a.m. in the morning. So everyone who works is leaving for work during that time, and the Kombinis tend to get really crowded. So in that sense, I guess it makes sense for Conan Pro to open up at 6 in the morning, because if people need hardware stuff for their job, they can go ahead and grab it from any Conan franchise from across Tokyo.
the play in between?
Yeah, we don't care about the play because it's gonna be held together by these. And even if there is play in there, we can always remove it by using plastic welding, but it's gonna be held together by using screws.
Yeah.
Be careful with the like solder, it's live.
Okay. Alright, let's try placing it here.
Yeah, so this part is gonna be really difficult for wherever, depending upon where you're based, to get the hex spacers right. The size differs a lot depending upon which country you're from or which manufacturer you're getting them from, and you have to try really hard to fit them in. Obviously the open source model, they the specifications they have given, they're using a specific nut for their design, but you will have to drill a hole in the 3D printed part to get your hex stand to fit in there if it's not the right size. We are close to 50 views in total during our live stream, which is
Yeah.
insane. It's just like simply insane. Yeah, and we are close to 1,000 subscribers on the channel, which is also like a really big milestone. So if you guys are viewing this content and if you haven't subscribed to the channel yet, be sure to hit that subscribe button. It's like it really helps with this content, and it's a big milestone in terms of YouTubing.
Yeah, it's almost time for sunrise outside. Like we've been at it
Yeah.
for all night. Towards the electronic side, we've been able to.
You know what would be so cool if we have a camera? We have a really beautiful view of the ocean just outside our lab. We can have a camera up there, and we can make a like weatherproof enclosure for it, and we can switch to that camera every now and then.
Yep. Would be cool.
Yeah, we can have the live stream on during different times of the day, and every now and then we can switch to the view of the ocean.
Alright,
And
now
especially like right now during the sunrise, it looks really beautiful. Yeah, we're gonna try to cook something with the camera setup in the next live stream sessions. We're definitely gonna try and cook something. But what I have cooked right now is another encoder done. So we only have 7 more to go. Let's try and finish them as soon as possible.
M3X55. I would need M3X55.
And
I think This one?
Yeah,
Or these ones?
yeah, you can measure these.
I think these are the ones. M3X55. So over here. Yep, this is the one. Yep, this is the one. It's 55 and it's M3. Can you pass on a couple of these? Like.
Yeah. Just give me a moment.
Let's see. Moment of truth. I think we've easily overdone this. You can see easily.
Yeah, no, all good. I don't think it will be a problem. Like whatever this thing will push on, it will keep it locked in the right orientation. Also, I think if a screw passes through this, it's gonna like get it the right way. It's gonna straighten it a bit.
There's an issue because this is also not gonna fit in here.
Yeah, just drill a hole through. Drill a big hole right through it. So hopefully these are the last few wires I have to cut. 1 2 3 4 5 6 7. We need 7 more of these yellow wires, and then we're done with cutting these yellow signal wires for now. Three, 4 more to go, and after that we are done with these pesky little yellow signal wires. The thing with working on these projects also is it's so easy to get your lab messed up while working on these projects. As you can see, the way we started and the way this table is looking right now. So what we try to do is we clean up right after working every single day, and that keeps sort of keeps everything in check. In terms of the tools in lab, because if you lose a tool, it becomes really difficult to find it right away. But also in terms of the general maintenance and cleanliness of your lab, because if you don't clean for a few days and you keep working, it becomes really difficult, and then you have to dedicate a few hours to sort everything together, to clean everything. So it's a good idea to, like, once we're done with this, what we're doing right now, we're gonna clean up this mess, and after that we're gonna start our next session later in the day. this solder iron tip is really hot. It's like 40 watts, and I can feel the heat from it right over here to my hands. It's also really cold over here from where we're from, and especially like I mentioned, during the morning time it tends to get the most cold. And yeah, I think because of that as well, the heat from this, it's a really like welcome change. The other 15 watt one, it's not in the frame, but this is a 15 watt solder. It's also live right now, but it's not emitting that much of heat. It's way easier to get stuff done by using this 40 watt solder most of the time. So if you're like if you regularly do soldering, or if you work with PCBs, if you are joining electrical connections like we're doing over here, I would definitely recommend going with 40 watt, 30 watt, 40 watt. These days you can also get variable temperature soldering stations, so you can just control the temperature of your solder iron. Now we're back to attaching these signal wires, and for the rest of the encoders we won't have to cut any new signal wires. Because pretty much all the rest of them are done, where we only have to attach these signal wires to 7 more of these encoders, and that's what we're doing right now. So let me try and put some solder over here. Once again, I'm going to go with the 40 watt solder because it's the most convenient most of the time to work with. And once again, when attaching these signal wires, you need to make sure to place them rightly in their spot, so they don't move around. So during operation of the robot or whatever you're building, they don't jump around, they don't get short with each other, because we don't want any short circuits during the operation of a humanoid robot. And a humanoid robot, generally, if there's reinforcement learning and training involved with that, you can expect a lot of bumping around, a lot of jerks to the body of the robot. And that's why these wires, they need to be like spot on in terms of their soldering and placement. So there is no short circuit or signal loss during the operation of the robot. Especially if you end up having a signal loss during the operation of a robot, it's a really tough job determining where that signal loss is in the robot or the device you've built. So it's better to make sure your connections are stable. So it's a good idea to spend a bit more time on soldering and making sure everything is okay, everything is locked in its place. That's what I'm making sure of right now, so that I don't have to find a fault in the system later when we end up having a loose connection. Okay, another one done. We only have 6 more to go, and after that we're gonna attach these to the motor controllers. It's a bit of a repetitive job after this as well, like connecting these to the motor controller. But after that, once all the encoder actuators for the robot are done, then we're gonna move on to the exciting part. Once this is done, all of these parts are done, we're gonna move on to the exciting part. Okay, let me make sure the other side is soldered in as well. If the wires were the right size, we wouldn't have to do it, but for all the encoders I have soldered so far, I've had to make sure to solder the other side as well, just to be safe. We have 51 views so far on our live stream, and honestly, it's really crazy, given that it's our second live stream. And I guess it's because of the weekend, like people are more
They're tuning in a bit more.
yeah, they're tuning in a bit more on the social media, and they're checking out our channel as well. We haven't had a comment yet on our any of our live stream, but there's a first time for everything. 50 viewers on the second live stream. Honestly, it's really crazy. Shout out to all the guys that tuned in. And yeah, it's gonna be less than a week before this robot is ready, and I'm gonna have a whole video up on my channel documenting the building process. So there's gonna be a summarized version of these live streams in that video, and I'm gonna show you the robot assembled together, and perhaps we'll also have that robot walking around, moving around, but I'm not too sure of that yet. But we're definitely gonna see the assembled one. Yeah, it's getting really cold here where we are right now. Generally in October, things are starting to cool down weather wise everywhere in the world, but especially here in Japan, it has started. The weather lately has been really cold. Snow-wise, in terms of snowfall, Tokyo, it does not receive any more of snowfall. Like maybe 2-3 times a year, if we're really lucky. But earlier on, it used to snow a lot in Tokyo, but because of all the global warming stuff, the weird, the stuff Trump really believes in, global warming, the stuff Trump is the biggest proponent of in the world. Because of that stuff, it no longer snows here in Tokyo like it used to a few years ago. Maybe 3 times a year. Yeah, and it's at like a really rare sight now to see snow in Tokyo. But in other regions of Japan, it snows really crazy. like Niigata, Hokkaido. It snows a lot in those regions. I am missing the blue wire now, so I'm gonna have to cut it for the remaining actuators. Once again, 6 blue wires. One. Yeah, I think we're gonna have to grab way more signal wires and also different gauges for our lab from Conan Pro. We might go there. It's about 6 a.m. in the morning over here, so it's just gonna open up in a bit. We might go there to grab signal wires, or we might go there during the evening time today.
It's not assembling.
If you can show it in the camera.
Yeah, so like this is the first attempt at 6010 actuator, and it's not assembling in as tight as it's supposed to. So most likely what I'm gonna do is, after some rest, whenever we come back online again, or whenever our next working session is, I'm gonna try another 6010 actuator, but I'll try to make it as tight as we possibly can. So a few of the parts in this one which are just not fitting in perfectly. For example, this hex stand is not going in perfectly well inside of this hole over here, and because of simple issues like this one, the alignment is not just tight enough. So we'll try fixing that later on. We might have to print 1 or 2 more of these 6010 actuators, but we also have many from the leg parts that we got from here.
in yeah, but might be a good idea to put 1 or 2 in print. While
I'll do that. I'll add some prints over here just now.
Alright guys, that's gonna be it for today. What we did in this live stream, if I can try and move this phone, yeah, so we assembled a lot of these actuators. We soldered them together, and I only have 6 more to go. I'm gonna complete them before taking some rest, and when we come back, probably tomorrow, for another live stream, we're gonna be working on these actuators before that, and hopefully we're gonna be working on finishing the final assembly of the motor and the controllers. These controllers, I'm gonna be soldering them with the encoders I have prepared over here, and we're gonna be working on the actuators as well meanwhile. So yeah, let's see how much progress we can make, and we're gonna update you in the next live stream. We have had a lot of views today, and honestly, thank you so much for joining this session. We're gonna be documenting the entire process of putting together this humanoid robot, and also gonna be making a summarized version of this process in videos as well. So if you want to later head out to that playlist, you can check that out. If you have any questions, or if you want to discuss anything, feel free to reach out to me in comment section down below. And thank you so much for watching this live stream. We're gonna be back tomorrow building more cool stuff.